A very good morning to our course lecturer and my fellow friends. Today, me and my friends are going to present a report which have been done before this. The report is about a level surveying. By the way, my name is NISHAAN Survey, son of BAALACHANTER. I am from DKA 3A. My metric number is 01 DKA 19F 2010. Let's we go to the content. In this presentation, we are going to explain about the introduction for this report, objective, equipments, fieldwork procedure, data collection, analysis and data calculation, and last is comment and conclusion. First one is the introduction. In this report, a task was given to the student to a survey in leveling. Students need to know the basic principle of leveling process, explain the setup, adjust the leveling equipments, state the leveling data, and adjust for the error. Before that, a student need to understand the surveying process and leveling process. Guys, surveying is the method of determining the relative position of the points of physical and cultural detail above, on or beneath the Earth's surface and depicting them in the usable form of establishing the part of points or details. The purpose of the surveying is preparing a map to show the relative position of the object on the Earth's surface, to collect the field data, analysis, and calculate the field parameter.
Hi, my name is Muhammad Fitri ZAIDI with number metric 01DKA19F2020. Definition of leveling. Leveling is to establish, verify or measure the height of the specific point with a datum. It is commonly used in a cartography to measure a geodetic height and a construction to measure height difference between the construction object.
Hello everyone, my name is KESAVARMAN son of GUNARAJAN, metric card number 01DKA19F2028, and I am from class DKA 3A. There are 8 leveling terms that can be found in our presentation: datum, benchmark, reduced level, temporary benchmark, backside, foresight, intermediate size, and change point.
The second is objective. The objective of this report is enable to have a basic knowledge on how to set up the instrument. There is a lot of procedure to set up the instrument before the leveling survey. Instrument setup plays an important role in the survey because any mistake in the setup will affect the data at last. So by doing this report, we can able to know the procedure to set up the instrument in the proper way.
Next objective, to apply the theory that have been taught in the class.
Third objective is to carry out level observation by using rise and fall method and height of collimation method from benchmark to temporary benchmark.
Next is a leveling equipment. In the leveling equipment, there's 4 equipment used in a leveling work, which is the first one is a tripod. It is used to support the automatic level.
The second equipment that we are going to see is automatic level. This equipment is used to establish or verify points on the same horizontal plane with a vertical staff to measure height difference.
The third leveling equipment that I am going to explain is staff level. A staff level, also known as a leveling rod, is a graduated wooden or aluminium rod used in the conjunction with a leveling instrument and determine the difference in the height between the points or height of the points above the vertical datum.
And the last one is a bubble staff. It is to ensure that the bubble in the center of the circle, which makes sure that the leveling staff or outer level is vertical and not tight.
Now we will move to the procedures. In this session we would see the procedure of installing leveling equipment in the fieldwork. There are 7 procedures that must be performed. The first one, collect the equipment that will be used for leveling work as in table 1 in 3.0 equipment leveling.
The second procedure is set up a tripod leg on the stable ground. Extend the tripod that can be adjusted in the length by using a lever clamp or screw secure that legs. The screw must be tightened after the leg has been set to the proper length, otherwise the portion may move while used, requiring instrument to be reset and all the readings retaken because the instrument height has been changed.
Third is attach the automatic lever to the tripod by tightening the tripod screw under the tripod that connect between the automatic level and the tripod.
Then plant all tripod legs firmly into the ground by using full weight of yourself to stable the tripod.
Consequently, center the bubble by adjusting the leveling screw at the automatic level. Adjust the bubble until the bubble stays on center while rotating the foot screw. Align the level on the staff by using the gun sight on the instrument's top and gently rotating the level by the hand. Finally, the leveling work can be begun.
Next is data collection. In data collection is the data that we get from the field work, and in this data we get from the figure 1. So from the figure 1 we extract the data from figure 1 to the table. We use that table to analysis the data. So in the table we can see the back side, intermediate side, foresight, and lastly is a remark.
The next is data and calculation. First, we are going to calculate the data for the rise and fall method. This method involves determining the level difference between the consecutive points by comparing each point after the first with one immediately preceding it. Based on the table, this is how we book the value of backside, intermediate side, and foresight. Now I am going to explain how to get the value of backside, intermediate side, and foresight. Firstly, set up the leveling instrument at the level position 1. Then hold the staff on the datum, reduce level plus 50 meter, and take the reading. This will be a backside which is 2.554 because it is the first staff reading after the level instrument has been set up. Then move the staff to the A and take the reading. This will be an intermediate side which is 1.786. Next, move the staff to the B and take the reading. This also will be an intermediate side which is 0.927. Then move the staff to the C and take the reading. This will be another intermediate side which is 1.9683. Then move the staff to the C and take the reading. This will be another intermediate side which is 1.983. Then move the staff to the D and take the reading. This will be the foresight which is 3.589. After that, set up the level at the position 2 which called the change point and repeat the same method to get the backside, intermediate side, and foresight until the point J. By using the same method, we will get 1.422 intermediate side at point E and 3.25 backside and 0.571 for foresight at point F. Followed by the point G, we will get intermediate side which is 1.925, then 3.015 backside and 0.46 to foresight for point H. Then last 0.780 for foresight for the point J.
Now we would see how to get the value of rise and fall. The first value, which is in the BS, we'll minus it with the second value, which is in the IS. If the answer that we get was positive, it will be in the rise. If the answer was negative, it will be in the fall. This method will be followed by the following values step by step. After calculating, we will get the sum of rise, which is 7.501, and the sum of fall, which is 2.779. The values that we get from the rise and fall will be used to calculate the RL. From the first RL, which is given in the diagram 50, we will add the values that we get from rise and fall step by step. If the value is from rise, we will add it with the RL. If the value is from fall, we will minus it from the RL. After calculating everything, the final answer will be 54.722.
Next is arithmetic check. So there's a formula for rise and fall method for arithmetic check. So the formula is a sum of the backside minus sum of the foresight equal to rise minus fall. So 10.124, which is sum of the backside, minus to 5.402, which is sum of the foresight, equal to 7.501, which is rise, minus to 2.779, which is false. So the answer we got is 4.722 equal to 4.722, which means it's okay, so the leveling is correct. So next is the analysis data for the height of collimation method. So by looking at the table, from the column backside to the forward side, we just take the data from the data collection. What we just gonna looking now is the sum of the backside. So the sum of the backside is 10.124, and the sum of for the forward side is 5.402.
Now we are going to see how to calculate the height of collimation and reduce level. Height of collimation is the method involving determining the elevation of the collimation plane for each instrument configurably and obtaining the reduced level of the point considering the respective plane of the collimation. There is a formula to calculate the height of the collimation and the reduced level, which is, first, to find the height of collimation, we need to plus the reduced level with a backside. Next, to find the reduced level, we need to subtract the height of collimation with the foresight. Another way to calculate the reduced level is by subtracting the height of collimation with the intermediate side. By using the formula, we can get the value of HOC, which is height of collimation, and reduced level easily as shown in the table. As you can see the table, the first value of HOC until the point C is remains same, which is 52.554, because there is no backside value to calculate the HOC. Then followed by the point D, which is 50.270 and remains same until the point E, and change at the point F, which is 52.949 and remains same at the point G, and followed by the point H, change to 55.520, and finally to the point J, which is 54.722. The next is reduced level value. The first value is 50, as we can see from the question. The next is 50.768 for the point A, 51.627 for point B, 50.571 for the point C, 48.965 for the point D, 48.848 for the point E, 49.699 for the point F, 51.024 for the point G, 52.487 for the point H, and last 54.722 for the point J.
Now we would see the arithmetic check in the height of collimation method. The formula will be the value of subtraction from the sum of backside and foresight will be equal with the value of subtraction from the last reduced level and the benchmark. After calculating, we will get the final answer 4.722 in the both sides. This means we have done the right calculation.
The next is the comment section. For the comment section, we are going to explain about the 5 main sources of the error in leveling. Even though the instrument setup procedure is followed in the order before starting the fieldwork, it is possible to make a mistake or error by leveling. Error or mistake will affect the reading in the leveling. There are 5 main sources of error in leveling as given here. The first is the gross error. Gross error, also known as a blunder, which is a significantly unpredictable error caused by the human error, resulting in the notable discrepancies. Carelessness, miscommunication, fatigue, or poor judgment are common causes of the blunder. The next is the systematic error. A systematic error or cumulative error will always be a same size in the sign under the same condition. A systematic error always addresses to the same definite mathematical or physical law, and correction can be done, determined, and implemented. Systematic error occurred due to the faulty line alignments and instruments that was not properly labeled and not correctly adjusted device.
Next is the accidental error, which is the unavoidable second step that can cause a surveying error, such as change in the atmospheric condition that are entirely beyond the observer control. Then the next is the instrumental error, which is the surveying error that can occur because of imperfection or faulty adjustment of the measuring instrument.
The final comment is personal error. This error can occur due to lack of perfection in human vision when observing and touch when manipulating instruments. This also occur due to the individual's limitations and skills and lack of experience.
In conclusion, leveling is very important and widely used in a civil engineering field for the planning and estimating the project work, and it also very useful for the student to carry out the leveling process in the proper method.
The third one, able to explain the principle of leveling and know how to set up and carry out the adjustment level of the instrument. The fourth one, arithmetic check was applied in both methods to check the accuracy of the calculation.
At last, we comment about the main 5 sources of the error that affect the reading in the level. It is very helpful to us by avoiding this kind of error when conduct a leveling in the future. It was a great experience for us, all students, to understand the scope of the site surveyor that helped them in the future. That's all from us. Thank you very much. At last, I would like to thank our course lecturer and my friends who helped us to complete this report successfully.